Okay, let's start now. Let's start. So today from the beginning, I'm going to start calculus part. Calculus part, very important session. Very important session. So see this one. Calculus contain limits, differentiation and integration. Limits, differentiation and integration. Then limits, very special concept, and differentiation also same, integration also same. All are new to you. Okay, all are new to you. Then limits, there will be your A-level paper definitely. Limits, there will be your A-level paper definitely. And differentiation also same, integration also same. So if you consider question number part A, there will be limit question, limit one question, and differentiation one question, and integration one question. Okay, part A paper, then there will be 7.5 marks for that. Then you, in part B, so here question number 14, differentiation part, differentiation. Then question number 15, integration part. And question number 12, part B, last part, there will be limits part. Limit application here. Limit application here. Then here 2.5 mark for pure paper, 2.5 mark for here pure paper, 2.5. And limits, here there will be at least 2 to 3 mark, 2 to 3 mark here. And for differentiation 15, integration 15. Then if you consider this, here 30, 37.5, 39, around 39 mark will be there for limits and limits, differentiation and integration part. Very important session. Okay. So this limits, differentiation and integration usually deals with different type of functions. No need to worry about the things about functions, but you need to remember just small properties of those functions. As an example, just exponential type, irrational expressions, and trigonometric functions, and polynomial functions, rational functions, so on. Okay. Then here differentiation, using differentiation we usually find gradient. Okay. Then differentiation foundation will be limits. Here limits is the foundation of differentiation. Then by the integration usually we can find sum. That can be area, that can be volume, that can be moment of inertia. So whatever it is, so to find continuous sum we can use integration. For some cases center of gravity, those things we can find practically by using integration. Okay, then here this differentiation and integration, very important part for higher studies as well. Very important part. So mainly in mathematics, in maths, we need to discuss algebra, we need to discuss calculus, we need to discuss coordinate geometry, and we need to discuss trigonometry. Those are the major part of mathematics, especially pure maths. Especially pure maths, these are the major parts. Therefore, calculus act major role in pure mathematics. Very important lesson. So we can't survive without calculus. That's the thing. Okay, very important lesson. Then here limit. You see. Consider this example. මේ ඉන්නේ මිනිස්සෙක්. මේ ඉන්නේ ගෙම්බා කියලා හිතන්න. හරිද? මූ මැත්ස් දන්න ගෙම්බෙක්. මූ කරන්නේ හරියටම මේ භාගේ පැන එනවා. මේ තියෙන ඩිස්ටන්ස් එකෙන් භාගයක් පයින්නවා. 1 කිලෝමීටර් නම් කිලෝමීටර් භාගයක් පයින්නවා. 1 මීටර් නම් මීටර්ස් භාගයක් පයින්නවා. 1 සෙන්ටිමීටර් නම් සෙන්ටිමීටර් භාගයක් පයින්නවා. 1 නැනෝමීටර් නම් නැනෝමීටර් භාගයක් පයින්නවා. හරිද? එතන මට කියන්නේ මේ ගෙම්බාට මිනිස්සයාගේ ඇඟ උඩට පයින්න පුළුවන් කවදා හරි. බෑනේ නේ. ඒ කියන්නේ ලං වෙන එක නෙවෙන්නේ. But he can reach. It can reach, no? It can reach. Then he moved towards the man. He moved towards the man, but anyway, the distance between M and G minus M distance, it goes to 0, very, very small. Here say delta means small value. Therefore, distance between M and G get very, very small. That's the thing. So, in mathematics, you discuss x equal A notation. Okay? Approximately equal A notation. Then here we're going to discuss x arrow A, x tends to A notation. X tends to A notation. So, in computer field, there will be another notation x equal A notation. X equal A. So here the exactly equal x equal A mean we can't change again x value. Then only x value equal A. That's it. But here the notation of this x equal A mean we have assigned A for x. We have assigned A for x. Then later you can apply any other value for that x value. But for this case, it is unique. It is unique. We can't apply further any values for x. But here we can apply. Then here x approximately equal to A. X approximately equal to A. Then you say x equal 1. Then x approximately equal, you know this idea. 1 mean not exactly 1, it close to 1. Close to 1. Then x arrow A mean x moves towards A. X moves towards A like this. X moves towards A. Then here we discuss about tendency. We discuss about tendency. Okay? X moves towards A. Okay? That is tendency. So if you consider this one as a real number line, here say some value here simple A, here say variable x, here A fixed value, A variable value. Then here right hand side tendency, it moves from right hand side, no? Then we say right hand side tendency. So if it move this side, then we call left hand side tendency. Left hand side and tendency. Here man, right hand side moving towards the man, then right hand tendency, then here left hand tendency. We have two different tendencies. Okay? Tendencies. Anyway, you identify this limit mean we consider about the tendency and what will happen when x goes to A. When x goes to A. Okay. So that is about limit. Okay, write down topic. Write down topic. Calculus. Calculus. Okay. Then subtopic limits. This concept new to you, very important and very easy lesson. Important and easy lesson. Okay, then again subtopic, limit of a variable point. 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 Okay, just write. Let's consider 2 points on the real number line capital A and P. Let's consider 2 points on the real number line capital A and P. Capital A and P. Where A is a fixed point, where capital A is a fixed point with corresponding real value simple A. Capital A is a fixed point with corresponding real value simple A. And let the point P is a variable point. Point P is a variable point. Point P is a variable point where the variable value simple x, as the given figure. Okay, now you sketch this real number line. Do with me. Here point A, here point P, here value here simple A, the value here simple x. Here we say AP distance, we usually denote x minus A by modulus. No? Modulus means we consider only about absolute value. We can only consider about absolute value. AP equal x minus A modulus. Sketch it soon. Okay, now write this say. The distance between 2 points A and P, the distance between 2 points A and P is AP equal x minus A modulus. If this distance is a very small value, then it is denoted by AP equal x minus A modulus less than delta. X minus A modulus less than delta. Delta means very small value, okay? Where delta is a very small real value. Then here we define the variable point P, is close to A. The variable point P is close to A. comma, the variable x has tends to a. The variable x has tends to a. The variable x has tends to a, which is denoted by x arrow a, which is denoted by x arrow a. Here we say x tends to a. X tends to a or x goes to a. Here this notation we say x tends to a or x goes to a. X goes to a. Here just a concept. Okay. With stomach write down, the variation of x, can be towards a, from the left hand side, or from the right hand side, These are known as left hand limit and right hand limit of the variable point. These are known as left hand limit and right hand limit of the variable point. Okay. So now we identify the variation of x right hand of a, we say right hand limit. The variation of x left hand a, we say left hand limit. Small thing. Okay, sketching with me now. Here real number line, here simple a, here x. So it goes like this. Then here x minus say modulus less than delta. Then here we call right hand limit. We denote by x arrow a plus. Then here real number line, a somewhere here, x somewhere here. Then here x minus say modulus, if that one less than delta, then it moves toward a from the left hand side. We call left hand limit. We denote that one x arrow a minus. Okay, these are the notations of left hand and right hand limit. So get idea when x arrow a minus mean, here minus he write as index. X arrow a mean x varies from the left hand side of a. So a plus mean it varies from the right hand side of a. That's the small thing. Okay, put that one. Okay, first you grab this content, then this will be a very easy lesson. Nah? Normally this is very easy, you can earn this mark easily. Okay. Now you consider here real number line, here a1 value, a2 value, then variable x tends to a1 this say, and the variable x tends to this one here this way. Here you consider no values between a1 and a2 again. Therefore here right hand limit x arrow a1, here left hand limit x arrow a2. Now we know left hand limit not equal right hand limit, no? So if a1 equal a2, then it is coincident, no? Equal to a. Then left hand limit, right hand limit both are same, no? Then left hand limit, right hand limit equal. Left hand limit equal right hand limit. Therefore, x arrow a plus equal x arrow a minus. Therefore, you can just write x arrow a without putting sign here. You no need to consider sign here. But identify there are two limits thing, left hand limit and right hand limits. But usually in A levels, we get both left hand and right hand limit equal condition. Then we don't put signs here. But there are left hand and right hand limits. There can be one side limit. Okay, put this note. Okay, anyway, this is we call limit of a point. Limit of a point. නිකම් මේක නිකන් just example එකක් හිතුවොත් මේ තියෙන ඔයාලා ගෙදර කියලා හිතන්න. මේ තියෙන පාර. ඔයාලට මෙහෙන් ඇවිල්ලත් ගෙදර එන්න පුළුවන්. ඔයාලට මෙහෙන් ඇවිල්ලත් ගෙදර එන්න පුළුවන්. දෙකම එකයි. හරිද? හැබැයි මේ පාරේ ඉන්නවා කියලා හිතන්න බල්ලෙක්. දැන් මේ පැත්තෙන් ඇවිල්ලා ගෙදර එන්න අමාරුනේ. ඒතර දෙකක් වෙනවානේ. මේ පැත්තෙන් ඇවිල්ලා කන්ඩිෂන් එකක් තියෙනවා. ඒ කන්ඩිෂන් එකත් එක්ක මෙයාට පාස් කරගෙන එන්න බෑ. හැබැයි මේ පැත්තෙන් ඇවිල්ලා පුළුවන්. ඒතකොට මේ දෙන්නෙක් වෙනවා. ඒතර ස්පෙෂල් කන්ඩිෂන්ස් තියෙනවා අන්න වගේ. අන්න ස්පෙෂල් කන්ඩිෂන් එකේදී මේ දෙන්න වෙනස් වෙන්න පුළුවන්. Can be different. Okay? But usually in A levels you get left hand right hand limit equal condition. Then no need to worry about this type of things. Okay, further you put this note. So here notations like x equal x arrow 2 plus, x arrow 3 minus, x arrow 0 plus, x arrow minus 3 minus, x arrow minus 3 over 5 plus, likewise these type of notations you will get. And also x arrow 2, x arrow minus 3, x arrow 0, Here x tends towards 0, x tends towards minus 3, x tends towards 2. So here x tends towards 2 right hand side, x tends towards 3 left hand side, x tends 0 towards right hand side, x tends towards minus 3 left hand side, x tends towards minus 3 fifth from the right hand side. No? These are the idea of this notation. Okay, better to put it. මේක මේ හොඳ ස්ටාර්ට් එකක් ආයේ මැත්ස් වලට එන්ටර් වෙන්නත් තියෙන. හරිද? කැල්කියුලස් කියන පාර්ට් එක. හොඳ ස්ටාර්ට් එකක්. ඒ කියන්නේ එන්ටර් වෙලා තියෙන කට්ටියටත් තව බූස්ට් එකක්. එන්ටර් වෙන්න try කරන කට්ටියටත් හොඳ බූස්ට් එකක් මෙතන මේ ලෙසන් එක. මේ ලෙසන් එකට coordinate geometry add කරගත්තාම straight line circus ටික add කරගත්තොත් ලකුණු 20ක් එතනත් set වෙනවා. ඒ ටික ලකුණු 60ක් තියෙනවා ඒකට. හරිද? ඒ දෙකෙන් විතරක් 60ක් තියෙනවා. කියන්නේ අර ලොකු වටේ තියෙන ලෙසන් ඔක්කොම අමතක කරලා ඔකට විතරක් එකට set කරගත්තොත් ඒ mark එක එනවා. ඒ කියන්නේ isolate lesson. Okay. Okay. Now see this one. Now mainly in mathematics, in pure mathematics, we mainly discuss about functions. Functions. Function is the major tool to describe in real world things. Function is the major tool. Therefore, this limit also deals with function. Okay. Then we have a thing called limit of a function. Limit of the function of a function. Okay, write down subtopic. Limit of a function. Limit of a function. Limit of a function. Okay. Now you see this one. Now you see this one. Here x-axis, y-axis. Let's sketch general function like this. Let's say f. Here the function. So the graph can be different forms. Can be straight line, can be parabolic shape, can be to piecewise type. There can be different types. Circular type, there can be different type functions. So anyway, function mean a relation between variable x and y. Relation between variable x and y. If you consider variable x here, then there will be corresponding variable y here. Let this point P. Then previously that point on a real number line. Okay, that variable point on the real number line. Now this case point on the curve. Point on the curve. Okay. Now you say this one variable point. Variable point. X comma y. Then you say here fixed point A. Then here it has fixed value A, corresponding fixed value, let's say L. Then A comma L, say fixed point. Fixed point means it can't move, but P can move. P can move. Then here this distance, we say x minus a modulus, we say distance x minus a modulus. So as our definition, if x minus a modulus less than delta, that means very small value, no? Then if this value very small, then it has so close to a, no? So close to, sorry, x has x so close to a. X tends towards a. So in such case, y also varies, no? As x, y varies. As x, y varies. So when it move like this, then y move like this. So as x varies, y varies. Then let this distance y minus L modulus, y minus L modulus. So as x goes to a, y goes to L. Therefore, y mean our function. Y mean our function. Therefore, as x goes to a, y goes to L, then limit of the function y is L. Limit of the function is L. Here as x goes to a, limit of the function is L. Limit of the function is L. So the variable x change with another condition. That's the thing. Just get an idea, that's it. Okay. First you sketch this one and write these things, that's enough for now. This concept very important. Okay, now you write this, say, let a function y equal fx, let a function y equal fx as the given figure, let the function fx as the given figure. Point on the function capital A within bracket simple a comma L, within bracket simple a comma L is a fixed point, and a point on the function P, within bracket x comma y, is a variable point, Next line. If x minus a modulus less than delta, if x minus a less than delta, where delta is a very small real value, then we say x tends towards a, within bracket x arrow a, x tends towards a within bracket x arrow a, like this. Okay. Now next line. The function has property where it varies with respect to x, where it varies with respect to x. Therefore, here the variable x, therefore here the variable x, and the variable y, has unique mutual connection, between them, Okay. Next line. If y minus L modulus, less than, here y minus L modulus less than, see this notation, here we call epsilon, here this notation, that's also a very small value, okay, write that one. If y minus L modulus less than epsilon, where epsilon is a very small real value, then we say the variable y has tends towards L. Okay, put another star mark and say, as x goes to A, here like this, y goes towards L. Here the thing, as x goes to A, y goes to L. Y depend with A, no? As x goes to A, y goes to L. Then here we say, as x goes to A, the variable, the function y tends towards L. Function y tends towards L. Therefore, here limit of the function is L. Okay. Now here we have new notation for that. See this one now. Here the notation we discuss about limit LIM. So mainly we check variation of x first. Limit as x goes to A, y it goes to L. Y goes to L, no? Then here we check tendency, no? Then no need to put arrow here. Here we just write L, equal L. So limit x goes to A, y equal mean the idea here goes to L again, because we check tendency here. Here the notation. Or otherwise, here y mean our function, no? Y mean fx. So you can write LIM, limit as x goes to A, y mean fx equal to L. Here the notation, limit of the function. limit of the function. Okay, write that notation. Same thing now, as x goes to a, y goes to L. Here this line we write that way, here compressed form. Limit x goes to a, fx equal L. Fx equal L means the variation of y tends towards L. That's it. Okay. Now here, for function also we have left hand limit and right hand limit. Left hand limit and right hand limit. Here x varies from left hand side now. Then as x goes to a minus side, y goes to L. You say here L1. Say L1. So let's sketch another one. Here x axis, y axis. Here function f. Then take this point A, capital A, fixed point. Here say L2. Then here variable x, here variable y, here variable point P. Now x varies from the right hand side of A. Then according to that y goes to L2. Then here we say right hand limit. Then here we say left hand limit. Left hand limit. Right hand limit and left hand limit. Okay. Then here we denote this one by here left hand limit. We denote limit x arrow a, you put minus here, the function fx that goes to L1. L1. Here left hand limit. Here the notation. So you need to change only here index here minus as x goes to a minus side. Then here left hand limit, we say right hand limit. Here notation limit x arrow a plus, here plus side no, then fx, the value let's say L2. We call right hand limit notation, here left hand limit notation. If both of them are same, we say function exists a limit. Function exists a limit. Okay. Here anyway identify here variation right hand side. We call right hand limit. Then we put x a plus. The value goes to L2. Then here the variation of x from the left hand side. You consider variable x. Okay. Then we say left hand limit. We change here sign minus, that value L1, okay, L1 and L2, they can be same or they can be different. Anyway, according to my graph, you can see they are like same, but there can be different cases. That's why I put L1 and L2. Then further one by one, I'll discuss how it is happen. Now for now, you identify that there is a limit called left hand limit, and there's another limit we call right hand limit. Two cases we have. Okay, which star mark write down? For function also, there's left hand and right hand limit. For function also, there's left hand and right hand limit. As according to the variation of x with respect to a. The variation of x with respect to a. Okay, now you sketch both. You can check a variation like this. So you tends x towards a, then you can identify the variable y tendency. So as x goes to a, y tends towards L. So here as x goes to a, you check the variable y tendency. It goes like this. Then x that tends towards L2. That tends towards L2. Get this idea clearly. Okay. Okay, with star mark, special point, very special point. Write down. When left hand limit and right hand limit are same, when left hand limit and right hand limits are same, when left hand limit and right hand limits are same, the function exists a limit. The function exists a limit. When left hand limit and right hand limit are same, the function exists a limit. Otherwise, function doesn't exist a limit. Function doesn't exist a limit. Function doesn't exist a limit. That means no limit. No limit. Okay. Now say this one. Another point, write it. Another point. The continuity of the function, the continuity of the function also can be discussed by the limit. Also can be discussed by the limit. Also can be discussed by the limit. Under that, write down left hand limit equal right hand limit equal FA. I'll say what is that. I'll describe this. but just write left hand limit equal right hand limit equal fa. We call the function is continuous at a. Then write down, then we call the function is continuous at x equals a. Then we call the function is continuous at x equals a. The function is continuous at x equals a. Okay, now let's see what is that. Yeah, this is also a very important concept. So here these major discussions only appear with your first term test. Second term test. Then other than that, you don't get these type of discussions. You get only corrections. Okay, now see a function. Here x-axis, y-axis. Take this function like this. Here point A, here point fixed value A, here L, here this point. Now you get another function. I'll give you examples, but for now you identify the type here. I'll get here a hole at A. Here A, here L. Here this is not a hole, and here there's a hole. Second type. Now you see another type. Here x-axis, y-axis. Take a function like this. Here A. These are piecewise type. Piecewise, two cases, two different functions for different regions. Okay. Now anyway, you identify here the value L1, here value L2. So this case, if you go along this curve, you can, without any break, you can go along the curve, no? We say continuous. So you can go through this path. So when you go right hand side, you can tend towards A. When you go left hand side, you tend towards A. Then you can meet that the point common, no? Common. And also it is defined. A is defined. So here ball mean it is defined. So now you consider this one. So you can go along this path. You can go along this path up to here and up to here. But there's a hole. There's a hole. Then you have to jump, no? You have to jump. There's a breaking point. That's a breaking point. Then that is not continuous at A. We can clearly see it. That is not continuous at A. Okay. Now further. So, but left hand, right hand limit, here right hand limit, left hand limit, they are same, no? They are same. Left hand, right hand limit same. For this case, here right hand limit one thing, left hand limit another thing, and again here not continuous at this point. Left hand, right hand limit different. Then here this function we call not continuous at A, and also that doesn't contain a limit. The function doesn't contain a limit at x equals A. But here function contain a limit. It exists a limit. The function exists a limit, but not continuous. It goes towards same point. Goes towards same point, but he can't exist at x equals A. That's the thing. And here this case, function exists a limit, and also it continuous at A. Continuous at A. Okay, that's the condition. Okay, you sketch each graph. Just sketch. We have to write some small things under or right side of them. Just sketch them. Okay. Now let's write this way. Here left hand limit equal limit x goes to a minus fx. X goes to a minus fx. Write with me. Say L. Right hand limit x goes to a plus fx equal L. Fa also L. Fa also L. Here function f. Fa equal L. Here 1, 2, 3. Then all of them are same, no? All of them are same. All of them are same. Then you write left hand limit equal right hand limit equal Fa. Write this way. Left hand limit, right hand limit equal Fa. Left hand limit, right hand limit equal Fa. Therefore, the function exists a limit. Therefore, function exists a limit as x goes to a. Therefore, the function exists a limit as x goes to a. Function exists a limit as x goes to a. Therefore, the function exists a limit as x goes to a. And also, it is continuous, and also it is continuous at x equals a. At x equals a. Continuous, no breaking point. It smoothly run. Okay, now go to here. Second graph. Here left hand limit x arrow a minus fx. Left hand limit, again that tends towards L. So we discuss the tendency, only about tendency, not exactly equal thing. When x goes to a, y goes towards L. Then can be that point exist or not, whatever it is, okay, but anyway it has tendency to move towards L. The right hand limit x goes to a plus fx, again L, but fa undefined. Here function fx, no? Function fx. Here a value undefined. Undefined. Therefore, say here first point, second point, third point. Left hand limit equal right hand limit, not equal fa. These two okay, but here it break at that point. Right all. Right all. Right hand, left hand limit same L, right hand limit L, but fa undefined because of this hole. I'll give you example for this type of thing. But you identify if there's a hole, then that is undefined, special case. fa undefined. Then left hand limit equal right hand limit, not equal fa. Under that write down. Therefore, the function exists a limit. Therefore, the function exists a limit as x goes to a. The function exists a limit as x goes to a. Therefore, the function exists a limit as x goes to a. But it is not continuous at x equals a. But it is not continuous at x equals a. It is not continuous at x equals a. The function exists a limit as x goes to a, but it is not continuous at x equals a. So here we discuss only about that point, not about all. We discuss only about that point, that's it. Okay, now you go to here. Left hand limit x goes to a minus fx. Then left hand side you come. Then here, according to that, y tends towards L1. Right hand limit x goes to a plus fx. So you come right hand side along the curve, then the endpoint L2. Therefore, it break left hand limit not equal right hand limit. So at here it break. No need to consider the other point. It break here. Left hand limit, right hand limit, two different. Therefore, we say function doesn't exist a limit. Function doesn't exist a limit as x goes to a. And that is not continuous surely. If it break here, then definitely that won't continuous. Write this. Left hand limit x goes to a minus fx equal L1. Right hand limit x goes to a plus fx equal L2. Then left hand limit not equal right hand limit. Left hand limit not equal right hand limit. Okay, now you write here. Therefore, the function doesn't exist a limit. Therefore, the function doesn't exist a limit as x goes to a. The function doesn't exist a limit as x goes to a for this case. And also, it is not continuous, and also it is not continuous at x equals a. It is not continuous at x equals a. Okay. Now you identify by this limit concept, we analyze the variation of a variable y, variation of y. That means we analyze about function again, different manner, about function. Okay, let's do few examples. Take this example first. Y equal x plus 1 as x arrow 1. Okay, you see this one clearly. Then I'll give you exercises. Here x axis, y axis, y equal x plus 1, a straight line. When x0 y value 1, when y0 x value minus 1. Here the curve, here the line. So I need to discuss at x goes to 1, x value 1 means somewhere here. Then corresponding y value you find, then substitute 1 plus 1, 2. Then here function fx equal x plus 1. function fx x plus 1. Now find left hand limit first. Limit x arrow a not a 1 minus function x plus 1. You have function x plus 1. Now x varies left hand of 1. Then if you take x somewhere here, corresponding y value here. If you take x somewhere here, corresponding y value here. If you take x some value somewhere here, corresponding y value here. Anyway, it moves towards 2. It moves towards 2. Therefore, left hand limit equal to right hand limit, limit x arrow 1 minus 1 plus, here the function x plus 1. Now x moves towards 1 right hand side. Now you consider x somewhere here, then corresponding y value here. When x comes to here, y here. When x here, y here. When x here, y here. Therefore, that moves towards 2 again. 2. No? Then left hand limit 2, right hand limit 2 as x goes to 1. By this you can say f1, substitute 1 plus 1, no issue, we get 2. Therefore, here we can explain left hand limit equal right hand limit. Therefore, the function exists a limit as x goes to 1. Function exists a limit as x goes to 1. Therefore, here you can write, by considering all, you can write limit x goes to 1, no need to put plus or minus here, you can neglect that, just write x plus 1. So if it is plus, 2, if it is minus, again 2, we get 2. Then no need to worry about its sign, no? No need to worry about its sign. The value is 2. Limit x goes to 1, x plus 1 equal to, the value is 2. Okay. Now, further, here f1, limit left hand, right hand limit same. Further you say, left hand limit equal right hand limit equal f1. All are same. All are same means this point exists. This point exists. That point exists means it is continuous at 1. Therefore, the function is continuous at x equal 1. X equals 1. Here graphically we can easily see that. Here we find that algebraically. Here algebraic discussion. Graphical discussion is simple, we can see that. Here algebraic thing. Okay, do that example. Okay, this type of analysis won't get for your A levels, but for term test there can be this type of analysis. Complete it. Okay. Now let's do another example. Let's do another example. See this one. See this one. You consider y equal x square minus 1 over x minus 1 as x goes to 1. As x goes to 1. Here example 2. Example 2. Okay. Now see this, huh? See this clearly. Now when you consider this, here let's do this way. x minus 1, x plus 1 over x minus 1. So we have common factor. So when you cancel this, let's see what will happen. X plus 1, that appear x plus 1. Then like same previous function. But x square minus 1 over x minus 1, x plus 1, actually it is two different. Because if you put x equal 1 here, 1 plus 1, 2. We get 2, ne? We get 2. But if you put x equals 1 here, 1 square minus 1 over 1 minus 1, then 0 divided by 0. 0 divided by 0. We get two different answers. Therefore, there's some small thing about this. Therefore, when x equals 1, here we get 2. But here, when x equals 1, it get different answer. Now, let's put another value. You put x equals 2, then 2 plus 1, 3. You put 2 here, 2 square minus 1, 3, 2 minus 1, 1. Then 3 over 1, 3. Then no issue. Then only that thing happen for x equal 1, not the others. Therefore, when you cancel in this factor, definitely you have to write x not equal 1. Now these two functions are same. When you write x not equal 1, then only those two functions are same. Otherwise, it is different. Okay? Okay. Now let's move further. Now let's sketch this one. So when you sketch this function, now it is like this. Here x, y, here intercept 1, intercept minus 1. So at 1, it is undefined. Undefined means a hole. That's how hole appear. Because of this upstairs downstairs common factor, that hole appear. Okay? Because of that common factor in both numerator and denominator. Okay. Now, if you consider right hand limit, then we get 2. If you consider left hand limit, we get 2 again. Then no issue, left hand, right hand limit same. Therefore, left hand limit x arrow 1 minus function x square minus 1 of x minus 1, we get answer 2. Right hand limit x 1 plus x square minus 1 over x minus 1 equal to left hand limit, right hand limit same, but f1 undefined. Here x not equal 1, f1 undefined. 1 square minus 1, 1 minus 1, 0 divided by 0, undefined. Therefore, left hand, right hand limit same, but that not equal with this. Therefore, we say function exists the limit, but it is not continuous. Okay. Now start writing. Left hand limit, right hand limit equal, but function f1 undefined. It break here. And also say not continuous. Not continuous. Now let's do another example. I'm going to discuss here three different cases. First one, continuous and exist limit. Second case, exist limit, not continuous. And third case, not continuous and not exist a limit. Okay, see this. Okay, see this example. Example 3. Y equal, here x, for x greater than or equal 1, minus x plus 1 for less than 1. Here two cases. As x arrow 1. As x arrow 1. That is piecewise function. So definitely for piecewise function, we know it is not continuous usually. It is not continuous. So when sketching piecewise function, it's not advanced thing. You sketch each function for different regions. That's it. Here y equal x. Y equal x sketch only for this region. That's it. Then here y equal x graph. You need to sketch for x greater than or equal 1. So at 1, the corresponding value 1, y equal x for x greater than or equal 1, this region. Equal 1 for that. Then y equal minus x plus 1. Minus x plus 1. Okay. Then minus x plus 1, here intercept 1, gradient minus. When x0, y1, y0, x value 1. Now it goes like this. That function for y equal x plus 1 function for less than 1 for this region. Then you get solid line only for this. That's how we sketch piecewise function. Simple thing. Okay. Now when you consider this one, right hand limit x goes to 1 plus side fx, say fx, here say fx, then here plus side. So it goes like this, then tendency 1, it goes toward 1. Left hand limit x arrow 1 minus fx, 1 minus. So it moves towards like this, then corresponding y value 0. So you check at the end point y value. So you go along this curve line and at the end point you check y value, it is 1. You go along this line, at the end point you check y value. Then right hand limit not equal left hand limit. Therefore, the function doesn't exist a limit. As x goes to 1, but all the other cases it has limit. Only for 1 it doesn't contain a limit. It doesn't exist a limit. And also it is not continuous, no? Now they are not same. And also it is not continuous. It is not continuous at x equal 1. At x equal 1. Okay, do that example. Okay, now let's do few another examples. Just to try these functions. For y equal, you do y equal 2x plus 1 as x goes to 1. 5 y equal x square minus 4 x minus 2 as x goes to 2. 3 y equal x plus 1 for x greater than 1 minus 6 for x less than or equal 1 as x goes to 1. Okay, you do that. Do soon. I'll give you a few time. Take time and continue. Do soon. Okay, time enough. Time is enough. I'll discuss with this one briefly. Y equal 2x plus 1. X-axis, y-axis. Here the graph cut at 1 and cut at minus half. So as x goes to 1, then corresponding y value is 3. Then left hand limit, right hand limit. Left hand, right hand limit both are 3, no? And when x equal 1, y value 3. Therefore, function x is the limit and it is continuous at 3. First one. Second one, y equal x square minus 4 x minus 2, x minus 2 x plus 2 over x minus 2, cancel the factor and say x not equal to, x not equal to. Then the graph here, y equal x plus 2 graph, here 2 minus 2 at 2, it is undefined, you put whole here, then corresponding value 4. Then left hand, right hand limit both 4, but f2 undefined, f2 undefined. Therefore, function x is the limit and it is not continuous at 2. Okay. Then here the function y equal minus x equal 1 minus 1 minus 1. Then y equal x plus 1 value 2. Here the graph. Then left hand limit minus 1, right hand limit 2. Na? Right hand limit 2, left hand limit minus 1. Therefore, left hand limit, right hand limit, they are different. Therefore, function doesn't exist the limit and it is not continuous. It is not continuous. Okay, complete that now. Okay, now you identify that is fundamental concept of limits, basic concept of limit. Okay, then usually you get here second type of expressions, second type of things. Here these are piecewise functions now. Here piecewise function, this one. Then for piecewise function that contain one side limit, left hand limit or right hand limit. So usually for your LL question, we don't consider about one side limit. But when you are sketching graph in differentiation, we have to check one side limit. We call asymptote analysis, horizontal and vertical asymptote analysis. Therefore, here one side limit thing we discuss only for graphs in differentiation. So that will be in question number 14, not direct limit question. But for direct limit question, part A question, then you get this type of questions. That means function exists a limit, but that is not continuous type. Function exists a limit, but not that is continuous. Okay. Then that evaluation we do using just algebraic method. Yeah, these are graphical methods, no? Graphical method, no? But in our case, we mainly focus about algebraic method. So when evaluating those type of limit, we have special cases, special techniques, special rules, and special theorems. So we will discuss that one later. Okay. What intro lagano? Okay. Now let's start again. Write down next topic. Evaluation of a limit. Evaluation of a limit. Evaluation of a limit with algebraic method. 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 Okay. Now see. Now previously we have analyzed graphical idea, geometrical idea of limit. And now I'm going to convert that into algebraic method. Algebraic method. Concept of that limit. Now when evaluating a limit, first step, you substitute x limit to the function. You substitute x limit to the function. See example, limit x goes to 1, x plus 1 over 2x minus 1. Here x limit, substitute to the function, 1 plus 1, 2 times 1 minus 1. Find the value, 2. Here 2 over 1, answer 2. So if that result defined, if that result is defined, then you say that is the solution. Simple step. First you substitute x limit to the function, then check whether it is defined. So if it is defined, it is a solution. So then you need to know what is undefined. You need to know what is undefined. So undefined things we have done in number lesson. 0 to the power 0 undefined, infinity minus infinity undefined, infinity divided by infinity undefined, 0 divided by 0 undefined, then 0 times infinity undefined. These are usual cases, undefined expressions. 1, 2, 3, 4, 5. So when evaluating a limit, first step, you substitute x limits to the function, then check the value. If value is defined, you say that is the answer. Infinity defined, infinity defined, then infinity is solution. But these are undefined. These are we can't take as solutions. We can't take as solutions. These are undefined expressions. Undefined. So when you substitute x limits to the function, you put equal here. Don't write limit now because we have substituted. No? We have substituted x limit. Therefore, further you don't write limit. Then the value is 2. That's how we do. Simple step. Okay, this is one type of question. Okay, right. When evaluating a limit algebraically, first substitute x limit to the function. First substitute x limit to the function. If the value is defined, if the value is defined, within bracket write down any real value between minus infinity to plus infinity. Within bracket write down any real value between minus infinity to plus infinity. Close the bracket. The solution is that. Okay. Now you do this example. You can directly substitute, that's it. That is special, one simple question type, but we won't get these type of questions. We don't get these type of questions, but it is one type of question. Okay. Then by the side write down undefined expressions. These are undefined expressions. These are not solutions. Undefined expressions. Write that as well. Undefined expressions. These are not solutions. 0 to the power 0, infinity minus infinity, infinity over infinity, 0 over 0, 0 times infinity. These are undefined expressions. Undefined. Get this idea. Any real value in between minus infinity to plus infinity, we take as solution. Infinity possible, infinity possible answer. These are impossible answers. That means infinity divided by infinity, we don't know. Infinity, we know infinity, but we don't know exact value. That's another thing. But infinity we know. The value we don't know. But anyway, you consider infinity is a solution for limit. Okay. Then these are undefined expressions. You don't take these are solutions. Okay. If you get undefined expressions, we have different techniques, different simplification patterns, okay, different rules and theorems to evaluate these type of limits. So we will discuss it later. Okay, let's do first type question, two, three questions. Okay, you do soon. Do soon. Do soon. Do soon. These are simple questions. You have to just substitute values. That's enough. Then simplify and get final answer. That is one type question. So when you are evaluating a limit, definitely as first step you do that. First in your mind substitute value and check whether it is defined or not. If it is defined, you take that one answer. If it is undefined, you need to go another path. Go along with another path. Complete soon. Here are the solutions. These are the solutions. You can just substitute. Check it now. Okay. With star mark write down. With star mark write down. For undefined expressions, for undefined expressions, for undefined expressions, for undefined expression, to evaluate limit of an undefined expression. To evaluate limit of an undefined expression. To evaluate limit of an undefined expression. Undefined expression. There are different techniques. There are different techniques. There are different techniques. First one, special simplification methods. Special simplification method. First one is special simplification method. Then subpoint, under that subpoint, factorization and removing common factor. Subpoint, factorization and removing common factor. That is one simplification method. So we will see what are the suitable for these steps. Okay, factorization and removing common factor. Second one, rationalizing irrational expressions. Rationalizing irrational expression. Rationalizing irrational expression. Special simplification type, rationalizing irrational expression and removing common factor. And removing common factor. Rationalizing irrational expression and removing common factor. Okay, then first one simplification, special simplification. Second one then, second one. Right there. By using rules and theorems, limit evaluation can be started. Limit evaluation can be started by using rules and theorems. Okay, rules and theorem, I'll discuss that one. Anyway, first step, you substitute x limit to the function and check whether it is defined or not. If it is defined, no worries, that is the solution. So if it is undefined, we need to go another path. So in that path, we can do some simplifications. We can use theorems and rules. Okay, let's see rules first. Rules. Rules on limits. See this one, rules on limit. First rule, limit x goes to a, here k constant. For constant, limit constant. That is one rule. Constant, limit constant, that won't change. Constant. Then second rule, limit x arrow a constant time function. If we have constant time function like 2x, you can take 2 outside, like bracket. Okay? If you have constant, you can take outside. With single constant, answer constant, with constant time variable, you can take constant outside. Limit x goes to a fx. You can do that one like a bracket. Third, limit x goes to a. If you have two functions which are separated by addition, that can be 2 or more functions, then you can separate limits like a bracket. Limit x arrow a fx, put bracket, plus limit x arrow a gx. Likewise, you can separate for each function. Each function. Okay? For each function, you can separate limit. So if you have plus and if you have minus, you can do same. If you have product, you can do same. If you have division, again you can do same. No worries. For any algebraic operations, we can do same. That is another rule. Okay? We'll discuss these things later. But anyway, you identify these rules. And rule number 4, limit x arrow a fx to the power n type. Function has power like this. So you can take this n outside from the limit. Limit x arrow a fx to the power n like this. Like constant, you can take outside, no? Then here for constant power, you can take it outside from the limit. That is another rule. And rule number 5, here limit x goes to a, this is a rare case, very rare case, x goes to a, fx to the power gx, here it is we call exponential type. Then power has variables. Power has variables. Here power only constant. Power constant, they are power variable. Then in that case, you can separate limit for each. Limit x arrow a fx to the power limit x arrow a gx, like that. Like that, you can separate limit. Okay, write rules and theorems. First write rules. Write them. Okay. These rules we need to select proper way. Yeah? That means for different type functions, we have to select different rules. We need to select proper one. That's it. Okay, now write this way. There can be different type functions to evaluate limits. There can be different type functions to evaluate limit. There can be different type functions to evaluate limit. Under that, write down one by one. Polynomial functions. Polynomial functions. Rational functions. Rational functions. Irrational functions. Irrational functions. Trigonometric functions. Trigonometric functions. Next, exponential functions. Exponential functions. Exponential functions. Next, logarithmic functions. Logarithmic functions. Okay, that exponential, logarithmic, those are some special cases. Those are special cases. Better to put star marks or special type question. Logarithmic function and exponential function. Then to evaluate those, we need expansions and we need furthermore simplification pattern. And especially, okay, see this, Anna. Especially for trigonometric function evaluation, we need to focus. Evaluation of limit of a trigonometric function, that must focus because that will be in your exam paper. Polynomial type you won't get because for polynomial type we can directly substitute. For polynomial type we can directly substitute, therefore you won't get that type of question. And generally you get rational function type and irrational function type and trigonometric function type. Those are generally we get. But exam focus, that goes to trigonometric function type. Okay. Now we have two different rules for evaluate limit again. So let's discuss that one as well, then all the theory part done. Now see theorems. Theorems on limits. So here we have two theorems. One is called limit x goes to a, x to the power n divided by a to the power n over x minus a type. Here theorem number 1. Here first theorem. So when you substitute this one, a to the power n 0, a minus a 0. Then we see that one as 0 divided by 0, no? 0 divided by 0. But we know 0 by 0, that is not a solution. For this case, we have solution n minus 1. You can directly apply this. n minus 1. 0 divided by 0, not a solution. But for this evaluation, we do use in theorem by n minus 1. So see example. Limit x goes to 1, x to the power 3 minus 1 over x minus 1. Here put 3, x to the power n, a to the power n, x minus a. N mean 3, a mean 1, 3 minus 1, answer 3. Answer 3, no? Then see another one. Limit x goes to 2, x to the power 2 minus 2 to the power 2, x minus 2. According to the theorem, here we must n here, both n and a 3 places, x in 3 places, x in 3 places. Now x in 3 places, a 3 places, n 2 places. Then according to the theorem we can write n mean 2, a mean again 2, n minus 1. Then answer 4. Answer 4. Likewise we can evaluate using theorem. Now theorem number 2, limit x goes to 0, sin x divided by x type. Here x must given in radian. So here we write answer 1. If you put 0, sin 0 divided by 0, undefined. 0 by 0, undefined. But we have solution for this. That is 1. 1. Here x in 3 places, here that must be 0. Then see example. Limit x goes to 0, 2x goes to 0, sin 2x divided by 2x. Then here sin x of x, 2x goes to 0. Then 1. Limit x minus 1 goes to 0, sin x minus 1 of x minus 1. Limit here x goes to 0, sin x of x type. Again 1. Likewise, we can apply theorem. So one by one later we will discuss, but you analyze to evaluate these type of limits algebraic way. So we have rules and we have theorems. That's enough. Okay. Then one by one we discuss all. Okay. Anyway, write down theorems on limits. Okay. Now let's do few questions. Let's do few questions. Here, write down limits of a rational function. Limits of a rational function. Limits of a rational function. With 0 divided by 0, with 0 divided by 0, undefined relations. With 0 divided by 0, undefined relation. Limit of a rational function with 0 divided by 0, undefined relation. With 0 divided by 0, undefined relations. Okay, under that we write down. Under that write down. When evaluating these type of limits, when evaluating these type of limits, when evaluating these type of limits, remove common factor both in numerator and denominator, both in numerator and denominator. Then substitute x limit to the function. Then substitute x limit to the function. Then substitute x limit to the function. Simple step, huh? Very simple step. Another star mark write down. With another star mark write down. To identify the common factor, factor theorem is used. Factor theorem is used. Factor theorem is used. By the x limit, it can be obtained. By the x limit, it can be obtained. Okay, see what is that? See what is that? Simple point. Huh? So there can be this type of questions for your term test. Very simple type. See this. Limit x goes to 1, x square minus 1 of x minus 1. When you substitute 1, 0 by 0. Then division we call rational function type with 0 divided by 0 undefined relation. Here rational type 0 divided by 0 undefined relations. Such case you need to remove common factor. Factor can be identified. Here it is. So when you put 1 the other side, the result will be x minus 1. No? When you put 1 the other side, the result will be x minus 1. That is the common factor. That is the common factor. Okay. Likewise, you can identify. Then you can factorize. This simple thing. No need to think like that. But anyway, we can factorize. But anyway, you remember that point. Here x minus 1, x plus 1, difference of 2 squares. Then cancel this factor, substitute. 1 plus 1, answer 2. Here you can cancel factor, okay? But previously I told you, you can't do that way. When sketching function, we can't do, no? We need to write x not equal 1. But here we can cancel because we don't consider about x equal 1. We only consider about x goes to 1, not x equal 1. Therefore, no worries, you can cancel that. Okay. See another one. Here 1, 2. Limit x goes to 3, x square minus 9, x minus 3. Limit x goes to 3, here x minus 3, x plus 3, difference of 2 squares, x minus 3, cancel common factor, then substitute. 3 plus 3, 6. So for these two cases we have theorem, but for now we don't use theorem, we just use simplification technique. So I told you when evaluating a limit, we have special simplifications. So this is one type simplification. One type simplification means factorization and cancelling factor, that's it. Say another one, third. Limit x goes to 2, x cube minus 2 cube of x minus 3, x minus 2. Here limit x goes to 2, x goes to 2. Here there's a factor x minus 2 and x square plus 2x plus 4 over x minus 2, x minus 2. Okay, then you cancel common factor, then substitute 2 square, 2 times 2 plus 4. Then the answer will be 4, 4, 4, 12. Likewise, this is different, one different pattern, one pattern. If you have rational type, you factorize numerator and denominator, cancel common factor, thereafter substitute. Then factorization, very important thing with this limit relations. Okay, do examples. Okay, after cancelling common factor, that 0 divided by 0 case goes away, okay. After cancelling common factor, 0 by 0, you can't do this, yeah. 0 divided by 0, 1, මේ වගේ වැඩ කරන්න එපා. සමානයි කියලා. හැබැයි මෙහෙම පුළුවන් limit x goes to 0, x divided by x, cancel and say 1. Okay. එතන cancel කරන්න පුළුවන්. Before substituting 0, we can cancel. After substituting 0, we can't cancel. Okay, 0 by 0, undefined. Okay. Then you remember for rational types, removing common factor is the important case. Then factorization very important, both numerator and denominator. Then thereafter cancel common factor. That common factor you can identify by the limit of x. No? X goes to 1, then factor will be x minus 1. X goes to 2, then factor will be x minus 2. X goes to minus 1, then factor will be x plus 1. Okay? Okay. Now you try to evaluate these relations. You do alone. Do alone. Simple questions. Okay, do soon. First identify common factor, then you can easy to factorize, then cancel common factor, substitute limit. So until you substitute the limit, you have to write limit LIM x goes to 1. After you substitute in the limit, don't write it. Okay, don't write it. Complete. Okay, you continue further. You continue. Do alone. Do them. Here this pattern very easy to identify. Yeah? So that is rational type. Rational type. Then thereafter we have common factor 0 divided by 0 undefined relation. 0 divided by 0 undefined relation. Then we can factorize and cancel common factor. No? Okay. Do them. Okay. Time's enough. Limit x goes to 1, x minus 1, x square plus x plus 1 over x minus 1, x plus 1, x to the power 2 plus 1. Cancel, substitute. Here 3 or 4. Limit x goes to minus 1, x minus 1, x plus 1, x plus 1, x square minus x plus 1. Cancel, substitute minus 1, 2 over 3. Limit x goes to 2. Here, do we have factor like x minus 2? Let's see. X square plus 3x. X cube, 2x square, 3x squared, x squared minus 6x 4 plus 4. X cube, 2x square, 3x square plus x square minus 6x, 4x minus 2x, 8. Okay, na? Then cancel common factor, substitute 2. Here 4, 6, 10, 14. Answer 14. Then limit x goes 0. Here x square plus 6x plus 9 minus 9 of x. Then cancel common x, substitute 0, answer 6. Limit x goes to 3 to x minus 3, x minus 3, x plus 2, x square minus x minus 6. Cancel, substitute 3, 2 over 5. Okay, check them. Now let's do another 2-3 questions. Let's do another 2-3 questions. Okay, you try. You try. Do alone. Continue. Continue. Do alone. Okay, time's enough. Here, we don't have any factors for denominator, no? Just substitute. That is first step, no? Substitute, get the answer. අපේ පළවෙනි step එක ඒකනේ ඒකම කරලා දාන්න. Substitute for 4 square 16 minus 12 minus 4. Then denominator minus 4 square 7 into minus 4 minus 4. Numerator 0, then answer 0. Substitute 3 6 6 12. Substitute 3 9 9 18 18 18 36. 1/3. Then last case we have factors. Last case we have factors. Then limit x goes to 2 5x square minus 2x squared 4x square 3x 2x cube 4x square 3x squared 7x squared plus 6x plus 1. Then substitute 2. 5 times 2 minus 1, 2 square minus 3 times 2 plus 1, 10, 9, 4, 8, 2, 3. Complete. Up to now we have completely done full theory part of limits. Then two question type. One question type direct substitution. Then second type rational type cancelling common factor. So we have to go another two types, irrational expressions and trigonometric expressions and so on. Then there are special limits type again, exponential and logarithmic type. Those are not with your A-level question, but anyway we have to analyze. Then let's stop for today.